Example 2, Fluid Mechanics. Chapter 5. Consider the equation for force as a relation to and viscosity. Develop a pi method to obtain dimensionless number. So at first we should write the f equals to the function of rho, v, l, and u, and we have in this case 1, 2, 3, 4, and 5 parameters. We should use a table for our 5 parameters to write their dimensions. For force, we have the dimension of mlt minus 2 power and L velocity LT minus 1 and rho ML minus 3, and viscosity have the dimension of M minus L minus 1, T minus 1, so we can find that the other dimensions M, L, T. So we have N equals 5, J equals 2, 3. We can obtain the number of pi function, which is k equals to n minus j. K equals to 2. From the dimension of our parameters, we can realize that LU and rho cannot form a pi group because there is only rho contains M and U contains T. So these 3 parameters don't have the same or parameters that be in all dimensions that be in all parameters, so they can make a pi group. For example, these 3 number can make a pi group because all 3 the mu can cover all 2 other parameters to make a group of pi, and also mu and u and l can form a pi group because mu can cover all other parameters dimensions. in these three cases, none of our parameters can cover each other, so these three parameters cannot form a pi group. In this case, we have the two pi groups. So we can continue. Select repeating j variables. We should repeating j variables to make a pi group. The first pi group is, for example, L, U, rho, the groups that cannot form a pi group. Multiple the other two parameters, those can form a pi group, in this case f and mu. At first we multiply to f, and pi 2 equals to the relation, for example, pi 2 equals to the three parameters those cannot form a pi group, which are L, U, and rho A, B, C, multiply to the other parameters that can cover the dimension of other three parameters, in this case mu. We select the power of -1 to place it in the denominator. If we don't use -1, the sign of ABC becomes the minus, and for this, from our previous knowledge, we select -1 for mu. At first, we should start with pi 1. Pi 1 equals to L, U, rho A, B, C, F should be equal to M, 0, L, 0, T, 0, our dimensions, which is equal to 1. So we can write the expression for f. We had M, L, T minus 2. For rho we have M, L minus 3. For L, and for U we have L, T minus 2. With multiplication we can obtain this relation. L multiply to U, L, T minus 2, multiply to rho M, L minus 3, multiply to the force, so we have this relation. For length L, we have A plus B minus 3C plus 1 equals to 0, and for time, for example, mass, for example, M, and we have minus 3 M. C plus 1 equals to 0, and for time we have this relation minus 2b minus 2 equals to 0 minus, this is minus 1. We have a correction here. Minus b minus 2, p equals to and a equals to the minus 2 again. So we have the relation for the first pi group. The first pi group can write as L minus 2 M the U minus LU rho minus 1 F, which is equals to, we can simplify, changes to better first pi group, which is our drag force. This is the first pi group. If the second pi group is pi 2, we can write L A L T minus 1 B and rho, which is M L minus 3 C multiply to the new dimension M L minus 1. We select T1, T minus should be equals to the M0, L0, T0. It we have for length A plus B plus, we have this relation A plus B minus 3C plus 1 equals to 0, mass C minus 1 equals to 0, time minus B plus 1 equals to 0. B equals to 1, C equals to 1, and A equals to 1. We can obtain the second pi group, which rho VL on U, which is the Reynolds number. This is the end of the example 2.